Now, if you're trying to work with a triangle where you don't know how long all the sides are, and you're trying to write some trig ratios, let's draw a triangle like this, and maybe like that. So what do we have here? Now let's try again. Let's go, how about 4 and 7? And then who knows how long that is, right? We'll have to think about it. So if you have this side here, which is 4, and you have this side here, which is 7, but we don't know how long this is, we could still write the trig ratios for that. Let's say we're looking at it from this, let's look at it from this angle up here. That angle up there, let's call that angle N. If we're trying to write the trig ratios, one of them we can write right away. Since we have here, this is the opposite side from there. Okay, what we have is the opposite side, and we have the adjacent side. But we don't have the hypotenuse. The ratio we can write right away is the tangent ratio, because we have opposite and adjacent. And of course, tangent is opposite over adjacent. Tangent op over adjacent, right? That's what that ratio is. So we're going to write a trig equation. Tangent of angle N equals 7 over 4. That's the tangent ratio. Now later on we're going to actually use an equation like that to find the angle, find the missing angle. Right now we're just writing ratios. If you want to write the other two, you need to know what this missing side is here, that hypotenuse. But you can find that, of course, using what you've learned earlier, which is the Pythagorean theorem. So if we're just going to call this h for hypotenuse, h squared should be 4 squared plus 7 squared. So 16 and 49, which gives us 65. Okay, h squared is 65. So h is whatever the square root of 65 is. Now I can write that as a decimal. It's 8 point something. It's a little bit more than 8. But I want to be able to sort of precisely write something here. Let's even grab our calculator so that we can have a look. There's enough of a calculator to see. Just for a second here, because all we need is, come on, square root of 65. 8.06. 8.06. Now we can write the other two now that we know that, right? If we know that that side are these things. You could write the sine ratio. Let's write the sine ratio first. Sine is opposite over hypotenuse. So if we put in our opposite is 7. I don't want to put in that decimal here, because if I put in 8.06, you notice on the calculator it was quite a bit longer than that. It's not exactly 8.06. This is not a true statement then, because this is not true. You could put in roughly equal to if you want and say it's roughly that. But also the other thing is this looks kind of goofy having a fraction with a decimal in it. If you want to write the ratio, you can say it's exactly equal to, in mathematics you're allowed to just write square root 65. That's called an exact value for that length. Sometimes mathematicians keep that. They don't actually work out what the square root is, because then they don't have to worry about all those long decimals. They have that exact number they can carry through. That's how you can write what the sine ratio is. And then the cosine ratio is, of course, now this is going to be adjacent over hypotenuse. So if we have our adjacent is 4, and then that missing side, let's put root 65. You could work out as a decimal what each of those ratios are, right? If we get this out of the way, let's move those. Let's actually shrink them down. Say this one here, right? That one you could work out, and you would come up with 1.75. 7 over root 65. You could, if you wanted to, you could work out what that is, right? 7 divided by square root 65. See, now I can just put in square root 65 here instead of putting in that weird decimal, because even if I put all the decimals that show on the screen, I still am not getting the whole ratio. 0.868 if we're rounding it off. So if we're rounding it off, we're going to say this one's 0.868. And then We can do that last one there. Actually, let's do it this way. Second entry. And I can go back. This might take longer than if I had just re-put it in, but that's okay. 0.496, roughly, if we're rounding that off. Try again. 0.496. Right, so that's writing ratios where you have a missing side. Use that Pythagorean theorem to find that missing side.